Transportation is a basic need of our civilization. In 2008, our road and highway system carried 1,000 billion ton miles of freight and 2,000 billion passenger miles. Those numbers add up to one major result: congestion. Building new roads is not the solution to congestion. The average car carries 1.6 passengers. T.H.A.T coaches will carry 50 passengers in the same driving space as 4 cars, while maintaining the same interval between vehicles as regular traffic. Trains are not the solution because steel wheels and steel rails require slow acceleration and deceleration, very low track slope, and a long turning radius. Finally, a killer for freight transport: rail cannot pick up nor deliver to the door. Our goal is to induce 50 million solo drivers to leave their cars at home and take public transportation for its speed. This video will describe our solution to the highway congestion problem. This is a preliminary design of the T.A.T high-speed automated transport system, also known as T.H.A.T. The ticket price shown here is purely used as an example. The actual cost of a trip would be determined by the distance traveled and current economic conditions. The T.H.A.T system will move people and freight at nearly 3 times the speed of today's road traffic, up to a maximum of 200 miles per hour. The major design principles behind this system are automation and safety. All tracks are one-way, which allows for high-speed operation. T.H.A.T vehicles are automatically controlled using proven technology for safe and efficient operation, such as guidance used in the Paris and Montreal subways for decades, and modern controls such as radars, sonars, transponders, and sensors that are commonly used today. The heart of the automatic switching system is the brig switch. Unlike today's rail switches, which require moving tracks under outside control, the brig switch uses a system of immovable tracks that let each vehicle switch itself when branching is needed. For the passenger, T.H.A.T provides comfortable coaches for modern transportation in a recognizable mass transit form. However, passenger comfort is equal to or better than private automobiles. A single dedicated track guarantees no interference from other vehicles, allowing a steady flow upwards of 2,000 vehicles per hour, which is currently achieved on highways under human control. When T.H.A.T vehicles pass through the brig switch, the control system operates 2 pairs of switching wheels to lead the vehicle on or off one track to another, leading to an entrance or exit ramp, or to a different track and destination. With speeds up to 200 miles per hour and automatic guidance from the guide walls and overall controls, T.H.A.T provides fast, uninterrupted transit times. The system makes it attractive to the solo driver to leave the car home for trips of up to 400 miles or so. Guide wheels along the side of the vehicle relay contact data to the vehicle's control mechanism, allowing it to operate at the appropriate speed and to steer along its proper course. The system can be used to replace automobiles. It can do so more efficiently than trains, which have limited reach, or than buses, which are caught in traffic, which is the original problem. For freight transportation, the T.H.A.T system solves several common problems. Automatic guidance eliminates the need for freight haulers driving up to 10 hours a day over long distances. Perhaps the biggest shortcoming of freight trains is that they are limited to railroad tracks, which are slow and suitable for massive movements of commodities, but not for everyday freight needs. Furthermore, freight must be delivered to the door. If not, it requires extra handling of the materials as they are transferred between trains and trucks. This becomes prohibitively expensive. T.H.A.T freight vehicles can leave the track and also operate as conventional road trucks. Since a driver is required only for local pickup and delivery at the endpoints over ordinary roads, the vehicle operates under automation for the long haul. A driver will take control of the vehicle only when it is used on regular streets. Guide wheels and switching wheels retract to allow operation on conventional roadways. Freight can therefore be loaded and unloaded at distribution centers using existing loading docks. The T.H.A.T freight system doesn't replace the entire freight infrastructure. It just improves upon the transportation by inducing highway freight vehicles to leave the road and use the track over most of their transits. Passenger traffic is handled similarly to today's mass transit systems. At the passenger station, riders still go to and from work like current commuters by walking or by using a taxi, a bus, or the subway. A national grid paralleling the current national highway system will reach all major cities in the country, as well as any that have sufficient traffic to warrant a station. And since such a grid has only on and off access ramps, but no intersections, it is more efficient, quicker, and safer than any available alternative. One lane of highway can carry 2,000 cars per hour. At an average of 1.6 passengers per car, this means 3,200 passengers per hour. A 4-lane highway with 2 lanes in each direction can carry 6,400 passengers per hour in each direction. But with 50 passenger coaches, a pair of T.H.A.T tracks can carry up to 100,000 passengers per hour in each direction while operating at up to 200 miles per hour. The T.H.A.T system provides modern mass transit composed almost entirely of proven technology already in use around the world to reduce today's highway congestion and traffic problems.